So we're nearing the end of our artificial intelligence chapter of our game here. And we're going to finish it off with probably something a little bit foreign to you guys, which is a state machine. And the state machine is just going to basically be the brain of our enemy here. So let's just go ahead and start making that right now. So I'm going to go to scripts, enemy. I'm going to right click, go to create. And let's make a script called enemy state. This is going to be our state machine for our Sentinel. So I'm going to drag and drop it and put it onto our Sentinel variable up here. All right. And a lot of this chapter is going to be going in and cleaning up some of our inspector. It's kind of bloated right now with public variables that don't necessarily need to be seen at this point. We just had them public before because they were showing us the information we needed to make sure we were debugging correctly if there were any errors. So we'll also hit up that after we set up our state machine. But to get our state machine going, we're going to have to just open it up and get started with some variables here. All right. And there's going to be quite a few. So bear with me here. All right. So the first thing we're going to do is we're going to set up our references. And I'm tired of typing in those references all the time. So I'm just going to cheat. I'm going to copy and paste all of our references we've been setting up. So I'm going to get these three. I'm going to put them in enemy animator. And why don't I go ahead and steal the code for the initialization. So I'm copy and pasting my initialization code for those variables. So that means I'm going to go into make a void awake function, set it up with my nice brackets, and we'll just copy and paste that. All right. Looks like we need a sprite object variable. So why don't we steal that again? So where's our sprite object? It's right there. So now we got that going on. Do we have, let's go over what we need. We need enemy site. We also need enemy attack. All right. And I'm just being safe than sorry. I mean, I think we'll need access to these, but it never hurts to have access to some variables like that. So why don't we just copy and paste this? I'm just taking shortcuts to get all this code done. If it's confusing you, then you can just take a breather while I'm doing all this, and then you can pause the video and you can just copy what we're doing. So it's the same thing we've been doing. We've just setting up our public reference variable or our reference variables right here, so we can get at different components in our inspector and all of the scripts we've been working with. So we got that going right now. So another thing we're going to steal is, if we go back to our player script, our Gambit controller script that I have going on, we're going to steal this whole state machine guy going on right here. This is what we need to do. So I'm going to copy and paste all this stuff. Remember, this is how we were able to tell what state we were currently in our console window. It would say idle, 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 walk, walk, walk when our Gambit was doing stuff. We're actually going to put this to work now rather than just spitting out a few, frames. So actually, why don't we just make it simple? I'm going to start with all my statics, and we'll pull it over here. And you got to be careful of one thing. Even though we're copying and pasting this stuff, it's only working because our idle states and our walk states and our projectile states, they're all named the same between Gambit and Sentinel. Remember when we copy and pasted our animator controller a few lessons back? Well, since we copied and pasted it, all these nodes and states have the same name. So that's how we're able to borrow code between these different scripts. So don't get confused about that. All right. So we got our animator. I'm going to pull animator down here actually, because I want to make an animator state info variable, current state info, like so. And I'm going to rename my current state, because what I really want this variable to do is to tell me my current animation state, not my current logic state or the current AI state or the bit of intelligence that our character is performing. This is purely what animation state is playing. So I want to specify this variable with anime state like so. All right, so I think we're good so far. Let me just double check. Yeah, so I'm going to hit Control S. And I want to see if I've broken anything. You guys know I'm pretty good at that. All right, so I'm going to hit play. And it's asking me, well, we don't have a sprite object yet. So we'll just drag and drop our Sentinel sprite down to our sprite object variable. Remember this variable right here, the sprite object variable, is how we access this game object, which has our animator controller attached to it. So that's a pretty important variable that we keep using. All right, so we got most of our variables set up. What are we going to do next? Now we need to go into our state script here, and we need to get into update and update what current state, what current animation state we're in. So it's going to be 2 lines of code. All right. Let's say current state. I messed up that. Current state info. What is that going to do? Equals animator dot get current state info on our base layer, which is denoted by the layer number 0. So don't forget the syntax here. So basically, we're using our animator state info variable right here to just straight up go into our animator and tell us what state we're in right here. Next, we need to update our current anime state. So we'll do current anime state equals current state info dot full path hash semicolon. So just a review on what that does. All of these variables right here, these base layers, the string to hash, basically we're assigning all these variables to the animation layer we're in. And this hash, string to hash, and full path hash, we're basically converting these names into integer values, integer numbers. So we can easily compare and set the different values for all these different states we have going on. So these 2 lines of code will constantly update what current animation state we're in based on their names, which have been converted into integers. That's not confusing at all. Excuse me. But trust me, it works. All right. So now we have our state machine pretty much ready to go and ready to do work for us. We've laid the groundwork. We got code that tells us what current animation state we're in. Now we need to drive the actions by which animation state we're in. So what does that mean? Well, all of our, walk functions here, set our destination, set update defaults, and all this stuff. Well, now instead of the logic triggering all this stuff, whenever we set our animation bool to walk, then we're going to call this logic from our state machine that we have going on here. So we need the following things to occur. We need 4 things to happen. We need conditions that trigger animation state transitions. We need some kind of public flag to tell other scripts, other attack scripts or walk scripts, what current animation state we're in. So we need a public flag for that. We need some conditions in our void update that change our current animation state based on what our player is doing in relationship to our enemy. So if our player is outside the enemy's field of sight, we need to set our animation layer to idle. Our sentinel is just sitting there. If our player gets within the sight sphere, then we need to set our animation state to walk so the sentinel can walk over. And if the player is close enough to sentinel to attack, we need to set our animation to attack in our animator window. And the last thing we're going to do is we're going to simplify the other scripts and convert some of the logic and some of the action we got going over there into functions. And we're going to start with that first. All right, we're just going to go in and clean up our other scripts here. So that's going to help us clean up our inspector and help our readability out quite a bit. So let's go over to enemy walk, and I'm going to select my sentinel over here. So we'll go into our enemy walk, and I think I'm going to keep most of these things the way they are. In fact, I might actually make facing right a private variable, so I'll just delete bool out of there because I know facing right's always working. I need to keep my sprite object public, and my enemy current speed, I'll keep that public as well so I know how fast my character's walking at a glance in my inspector. All right. So if we go to our enemy site, well, let's just stay in enemy walk for right now because we need to go in and make some new functions. So right now, our update uh, function right here in our enemy walk script is full of all the logic we need to get our player animating and to get our player walking to a destination. We're gonna flip the script here. We're not gonna make a void flip script. We're gonna change it up. Bad saying. All right, so we're gonna make a void walk function. And we're going to take some of this logic right here and put it into our void walk. So the first thing we're going to do is we're going to copy and paste Control X, to cut and paste our flip logic. We want that flipping working into walk right there. All right. Next, why don't we access our nav mesh object and we can update our speed just the way we want it. So I'll take my nav mesh speed, enemy speed. So anytime I go into my walk function, my speed will be set to our enemy speed that we want. So if anytime my speed gets set to 0, anytime I trigger my walk function, I'll make sure we're walking at the speed we need to be walking in. And then most of this is going to be copy and paste. Enemy current speed, we need to take care of that. Enemy current speed equals nav mesh agent dot. We're going to get the velocity of our nav mesh agent, and then we're going to get the square magnitude of it to convert that velocity, which is an x, y, z value, a vector 3 value, into a float, like so. And then why don't we just go ahead and copy and paste these two lines right here. We're going to put our set destination logic in and our update rotation equals false logic. We're going to nestle that right under there. All right, so now we're just going to go up to our void update, and we're going to leave it empty for right now. So now we have a void walk function that flips our character when we're walking, and it takes care of our speed. It updates our current speed so we can see how fast our enemy is walking. It sets its destination, which drives the actual motion of our enemy. And we're making sure we're not getting that weird rotation we struggled with a few videos back. And while we're at it, let's make a void stop function. And this is going to be the hardest function we're going to make yet. So bear with me. Nav mesh agent dot. No, see how hard that was? I misspelled something. Okay, we're done. So that's our void stop function. All right. Anytime we need to stop, we're going to tell our nav mesh agent, which drives the locomotion of our enemy, we're going to tell it, okay, no more paths. Stop where you are. No more destinations. All right. So that's our enemy walk script all set up. And we're going to come back to this update in a second. But right now, we're going to leave it blank. So why don't we go in and clean up our attack script next? All right. So this one's going to be even easier. And the hardest part will be making sure you don't put this void function in the wrong place. So remember, when you cursor next to these brackets, you can see the corresponding brackets. So we want to make sure we put our void attack outside of our void update. And our void attack is pretty easy. I want to point out something real quick in our enemy walk. You'll notice that we left out our animator.setBool. our enemy walk is not going to control our walk animation anymore. All right. You'll see why in a little bit. But let's keep on working on our void attack function right here. And this is easy. We're going to copy and paste all of our attack logic right here. We're gonna leave out that if statement that drives the logic for when we should start attacking. We're gonna leave that out for right now, and we're just gonna put it right in there. And you know what? We're gonna get rid of our animator.setBool line that drives our animation, but we are gonna keep our navmesh agent.reset. And now we can get rid of that if statement. We're not gonna leave this empty because we need attack to be constantly updating our current sprite so we know what frame we're going to be in. But you know what? Maybe we can put it into void attack, but I've just opted to always have something updating what current sprite's being drawn to our character. So if I need to come back to it, I'll know it's always updating whether or not we're attacking or not. So I'm going to keep that in update, always updating for us. All right. So that's it for cleaning up our attack script. Why don't we go to our enemy site script? And right now, our enemy site script is just so full of different variables and things that are public, and it's kind of cluttering up our inspector right here. So why don't we go in and make some of these variables private? All right. So which variables are we going to make private? All right. So first, I'm going to keep the variables that I definitely want to see. I definitely want to be able to keep seeing if my player's in sight in my inspector. I want to keep seeing if my player is on the right. So I'm going to copy and paste this up there. I'm going to try to keep all my public visible functions together on the top of the screen. I want to be able to see my target distance. And I want to be able to see what my target currently is. So we'll do this. The rest of them, I'm just going to delete the public from. We don't need to see what's going on with those anymore. They'll just work behind the scenes for us as private variables. What Control S, and theoretically, you can make all of this private because I don't. Actually, I lied. You won't be able to make target distance or player and site private because we have other scripts that rely on these two variables to drive their action. So we're just going to keep those for public just to make sure we're able to access them from other scripts. So if I hit Control S, it looks like yeah, not as many stuff in enemy site right there. Enemy attack's a little full because we have all these different game objects that drive our hitboxes and whatnot, but that's okay. Enemy walk looks good, and our enemy state's still looking good too. All right, great. So let's go on to the next part. This video is going to be a little bit long, but there's a lot to do with this state machine. But we're almost done. We're pretty much done. So let's go back to our enemy state script, and we're just going to start giving our character a brain now. All right. So why don't we go ahead and dictate the logic we need to start driving the actions of our enemy. And a lot of this stuff we've probably already done in previous chapters. We're just putting it in our enemy state machine next. The first thing we're going to do is we're going to dictate the conditions in which our enemy starts attacking our player. So we know we want our enemy site.player in sight to equal true. We know we want our enemy to be able to see our player to start attacking. And enemy site dot target distance needs to be less than enemy attack dot attack range. That's something we've already set up. And why don't we go ahead and set some logic for our attack delay? You'll notice that in the enemy attack, we have this attack start delay. So why don't we just do this? It's going to be nav mesh agent dot velocity dot get the square magnitude. So turning that velocity value into a float is less than. Let's bring up our enemy attack script dot attack. What is it? Dot attack start delay. And those will be the three conditions. I'm pretty sure I still have an attack start delay, don't I? Yeah. I don't know why it wasn't auto-completing. Was I misspelling it? Just to make sure my awesome syntax is awesomely correct. I'm just going to copy and paste it. I'm not going to make a syntax error right there. That's for sure now. All right. So these three conditions are going to be what dictates when our enemy starts attacking our player. If the enemy's in sight, if the enemy's close enough to the player to start attacking, and we have a variable that controls how soon the enemy will start attacking. So basically, we're going to base our start attack delay on the actual speed of our enemy. So now let's go in and add our brackets. Undo that auto formatting. Let me. I need to make my window bigger now, don't I? There we go. All right. So what are we going to do here? So we got the logic and the conditions to get our enemy to start attacking. Well, now we're going to call our animator, and we're going to call our attacks. And just to make sure that we're not in our walk animation anymore, just to be double sure, I'm going to set walk to idle, or walk to false, rather, like so. All right, that's the first bit of logic to get our enemy attacking. Next, we're going to go to when our enemy starts walking towards our player. So we're going to do an else if. Else if enemy sight dot player in sight equals true. And that's all we have for that bit. Because we just want to start walking towards our player if they're in sight. All the rest of this logic must be true. And we put it before our walking animation. So why don't we go ahead and trigger our booleans. Oop. And I'm going to make sure we're not attacking anymore. I'm just going to be double sure on that bit right there. All right, so the reason why we ordered these like they did is because we want our attack to take precedence over walking, because our attack has all these different conditions. You'll notice that attack right here has the same condition as our walk, but for attack to occur, these two things also must be true. So if we're in sight and we're still not in range of our player, then we're going to skip this attack call, and we're just going to keep walking to our player here. And then we'll do one more else if. Else if enemy sight dot player insight equals false, meaning we're not inside of our player here, and Control Z to get rid of that auto formatting. Then we're just going to, I'm going to steal this code right here, copy and paste it. We're going to set both of these defaults. All right. So these three if statements here drive what's going on in our animator window right here. And from our animator window, we're going to be able to set flags for what state we're in. That's crazy sounding, but this is what's going to happen. So now we need to have some kind of system where we can tell the rest of my scripts here. Let me get rid of that Gambit site. You can tell the rest of my scripts what current animation state we're in. All right. So we're going to keep on going down. We're going to skip a few lines, and we're going to have some more if statements going on. So if current NM state equals idle state. What's going on here? I thought I had a current. Look what I've done. I'm in enemy attack. Don't make that mistake. So let me go back to my correct script here. Jeez. All right. If current enemy state equals idle state, then we want to do something, right? What do we want to do? We want to set flag to idle. And when I say flag, I mean it's just some kind of like message, or like yes, this is true. This is happening. Let's do something now. That's what flags are, and they're really basically handled by booleans. But we're not going to make booleans here, and we can just keep on going with our logic. Else if current anime state equals walk state, and you can kind of see the trend we got going on right now. Attack state. All right. Attack one state. There we go. So these guys right here are going to look and see what animation state we're currently in, as dictated by all these conditions, and it's going to set our current anime state, or it's going to check and see what our current anime state is, so we can set our flags. So these flags are going to talk to enemy attack and enemy walk. So we need to make these flags now, and we're going to use a variable type. I don't know if we've ever used it before, but it's pretty beautiful. It's going to be an enumerator. So how do we use enumerators, and what are they? First, let's make it. Public enum. So it's going to be a public variable that we can see in our inspector of type enum, and we're going to say current state enum, and this is where things get wild. Idle equals 0. It's almost like a list of different variables here. And notice we use curly brackets here. All right. And then we're going to make a public current state enum, and we're going to set it to current state, logic state that we're currently in. So what just happened? Well, we made a enumerator with a list of different types of, I don't know, strings right here. And then we've actually called a public variable current state. So this right here kind of just populates our enumerator, and this actually declares our enumerator as a public variable. So this line of code right here doesn't make it show up in our inspector here. All right. This line of code is what makes it show up in our inspector. This is what declares it. This just populates our enumerator. And let me just quit talking about it and let me show you what enumerators look like over here. All right, so if we go to our enemy state right here, here's our current state. Look at this awesome drop-down menu. Pretty swift, huh? So this current state, this enumerator, is what's going to tell our other scripts what current state we're in. And we have a bunch of different ones we can populate in our current enumerator state right here. So I'm going to go back in and fill in these comments. And we're going to make use of my enumerator right here. So current state equals, we're going to call our populated enumerator thing up there dot idle. And we're just going to use that same kind of logic, that same, pretty much the same script here. And all we're changing is what enumerator, what drop down enumerator we're wanting to call. So current enemy state does this and that. Why don't we test? We haven't tested in a while. All right. Right now, we don't have any actions drawn. Right now, we just kind of have nothing going on, right? So nothing's broken, but we still haven't added the logic that we need here. All right, so let's keep on going here. So what are we going to do now? Well, now we need to go to our other scripts, and we need to be able to look at our current state flag that we have going on here. So we're going to go to, we need to make a reference variable to our enemy state. And we need to initialize it like so. And now in our void update, we can say the following. All right. We can say if enemy state, and this is where it all comes together, guys. Current state. So if the enemy state, current state, what is it going to equal? If it equals enemy state dot current state enum dot attack, then we're going to call our attack function that we made right here. All right, and we're going to do the same thing for our walk. So in our walk, we're going to have to make a enemy state function here. So I'm going to go to enemy state, just copy and paste it, and I'm going to copy and paste our initialization of that reference variable, like so. Hit Control S. Now we can update our walk right here. So if, and in fact, I'm going to copy and paste even more. So we're getting our current state condition, and I'm just copying and pasting it over here. If the current state equals walk, we're not going to call our attack function anymore. We're going to call our walk function. And then we need to know when we're idle, so we're just going to nest that in an else if else statement. If we're in idle though, then we want to call our stop function. And our stop function just resets our path here. So I think we're about done. Now comes the moment of truth with our state machine. So let's press play. All right. Awesome. And awesome. Now our, oh sweet. Now our enemy stops attacking when he's not in range anymore. And let's see what happens whenever he gets out of sight. So I want to bring the Sentinel over here. He's going towards the back. So I'm going to get out of his sight of range. Now he just goes idle. And I want you to pay special note to the current state as I'm doing things. So now current state is walk. And when he starts attacking, the current state is attack. If we look at our animator window here, we can see how our logic is firing off these different nodes. And when we do one, then the chain of attacks goes through his combo. We get far enough away, and he should go back to being idle. All right, so that does it for the enemy AI videos this week. This was a long video, but state machine is what controls everything. And I'm going to walk us through it one more time and tell you what you guys need to figure out on your own for this assignment. Okay, so in our enemy state machine, we've referenced all of our scripts and all of our nav meshes. And what's going on here with all this code is that we're looking at our animator window. Let me minimize this a little bit so we can see what we're saying. We're saying, okay, I want to get to my animator window, which is right here. And I want to also have another type of variable called the animator state info, which we're going to call current state info. This variable houses what current node is cycling. So right now the current state info would say, okay, idle's going on, idle's going on, idle's going on. And all this code does right here is convert these nodes into integer values so we can compare what animation state we're in versus what node is playing. So all this stuff, that was our just our way where we can get at the values in our animator state window right here. All right. So then we reference or initialize all our reference variables here to get at our other scripts and other components. And then we come into our void update, which drives the logic of our, this is the brain. This basically is the brain. These if-else statements. This is the brain of our enemy right now. Let me get rid of this. That's just some extra code I had in there. These if-else statements are the brain, meaning we have conditions and we have triggers that trigger our parameters in our animator window. We're currently in block now. So when our brain says all of these conditions are true, then it says, okay, go to my animator window and start playing this animation node. So we're currently in our idle state. Then we take that information and we come to these conditional if else statements and we update our current anime state. All right. And remember our enumeration flag? This guy right here talks to the rest of our scripts, attack script and walk script. It talks to it and says what current animation state we're in our animator window. So when we go to our enemy attack, in fact, I'm just going to get rid of this start function. We don't need it. So we're constantly in our attack script right here. We're constantly checking to see what current state we're in. This void update is constantly saying, okay, what's our current state? What's our current state? What's our current state? If it ever equals attack state, that means if attack animation is ever playing, then we're going to trigger our attack function, which makes our character stop walking, and it fires off all of our game objects, our active hitboxes that are going to be damaging our opponent. Same thing with walk. We're constantly checking to see if our walk node's playing. Right now, our idle node's constantly playing, so our current state is idle, so we're going to call this stop function. And stop basically just make sure that we're not having any destination, we're not walking towards something. But if our player is in sight, then we're going to set our walk parameter in our animator window to true, like so. See how it's true? Now the walk node is playing. All right. So we have walk set to true. Our animation loop is going through our walk node here in our animator window. So if our current anime state is walk state, then our current flag, this is our flag, our current state, we're going to set that enumerator right here to walk. So if we go to view our sentinel, our current state is now set to walk. So we go over to our walk script, and it's constantly checking to see, actually right here, we're constantly checking to see what current state we're in. And now finally, our current state, as noted right here, is set to walk. So we call our walk function right here. All right, so I've explained it enough times. I'm not going to go over it again. I hope you guys can wrap your head around it. It's pretty simple. Basically, all we're doing is we're checking to see what animation node is cycling through in our animator window. And then we have this flag right here that changes depending on what animation is playing. And it tells us in our other scripts here, should we walk towards the character or should we attack? Okay, that's a brief overview again. So what we're going to do for the rest of this chapter is I want you guys to start figuring out collision. All right, I want you guys to figure out whenever attack box 1 hits Gambit's hitbox, guess what you're going to do when that happens, when that finally makes contact. No longer is, Q going to trigger that. Let me just restart this. No longer is me pressing Q on the keyboard or Y going to knock me down. Instead, whenever this attack box collides with my hitbox, you're going to fire up the hurt node right here. So that means you're going to have another state right here called hurt equals 3. All right. And when this hurt equals 3, then let's see. That state's going to play. Well, there needs to be some kind of logic right here, I guess, right? That dictates whether or not we've been hit. So you're going to have to figure out, make some collision scripts and attach them to your boxes here. And those collision scripts are going to have to tell our state script right here if we've been hit. All right. So these boxes, these collision scripts that you're going to make are going to tell our enemy state what's happening. So it'd be something like, I'll comment this out. If collider script tells us we have been hit, then we set bool hurt to true. So that's basically the logic that you guys will use. I think the hardest part is going to be making sure that the hurt animation and the attack animation don't like clash, violently with each other. Making sure that you get the actual gameplay under check, because you could technically hurt somebody and have them do their like hurt animation, like right here with Gambit. But I mean, that doesn't last very long, right? We could go straight out of our hurt animation straight into attack. And I don't know if you've played a lot of beat 'em ups, but when you attack somebody, guess what there is? There's like a stun duration. So after we attack the Sentinel, we don't want him immediately attacking us back. Try to figure out a way to kind of have him stunned, inside that hurt animation or whatnot before he starts his attack animations again. So that's your assignment for this week. Figure out how we can get the hurt or is hit flag to pop up. Wow, he's having a seizure right now. All right. So I think you guys know enough about the state machine and enough to get this going. If you have any questions, please let me know through email. And if you're having a problem with your code, make sure you pack it up in a package. To do that, you just highlight assets, right click, export package. You'll get this window. Make sure everything in your scene selected, and you export. I don't know why I'm telling you guys this. You guys have done this countless times. But whenever you have a question in an email, it wouldn't hurt to send me your whole package so I can see what's going on with your code. So good luck. Hope you guys are having a lot of fun with this assignment. Because, right now, we got a game. We just need to get some collisions going. We need to get like health meters and scores and enemy spawns. So after we get our combat set up after this chapter, the rest of the project we're working on will be setting up the actual game logic, like our score, progressing through the level, spawning our enemies, and things like that. All right. So this video's ran really long. I apologize, but a lot was covered here, a lot of necessary stuff, and hope you guys have fun with it.